So this lesson actually begins kind of in the middle of page 8. It's kind of a random place for it to start, but it allowed us to save a little bit of paper. So what we're going to do is use some of our properties of exponents to solve some of these equations where all of a sudden a variable pops up in the um, in the exponent, right? So right here you see 5 to the third equals 5 to the x. Well, what happens? If we can set these things up where the bases are equal, we can just set the exponents equal. So in other words, to solve this one, 5 to the third equals 5 to the x just equals 3. But sometimes we have to use our properties of exponents. So for example, 5 to the x equals 25. Well, right now, I don't have the same exact base. That's 5 and that's 25. So what I'm going to do is kind of play a math trick. And can I turn one of those into similar bases? Well, 25, we should understand, is the same thing as 5 squared. So in other words, I can turn this whole problem into 5 to the x equals 5 squared. Rewrite 25 as 5 squared. Now all of a sudden I have the same base, which means I can put the exponents equal to each other, and that tells me x equals 2. We look at number 2 here. 36 and 6 aren't the same base. However, I know 36 is 6 squared. So what I can turn this into, 6 squared x plus 3 equals 6. Now, using my properties of exponents, I know I can multiply those two things together. I can multiply, right, these two things together. Also, property of exponents tells me that this is really like saying 6 to the first. So, in order to solve this, what I end up doing is I have 2 times x plus 3 equals 1. And now I can distribute, so 2x plus 6 equals 1. Don't have a ton of room here. So subtract, so I have 2x plus 6 equals 1. So subtract 6 from both sides, which leaves me with 2x equals negative 5. Divide both sides by 2, which tells me x equals negative 5 over 2. So the trick I'm playing is just turning some of these things into variables I already know. Some of them are going to be a little bit trickier. Now, for 19 and 21, just turn these into equals. That was a mistake that we made. Um, number 20, actually, well, I'm going to start right there. You can see they're both 7s. So I don't have to do any tricks here. I can just say 6x equals 2x minus 20. Now, start solving. Subtract 2x from both sides. So now I've got 4x equals negative 20. Divide by 4, divide by 4, so x equals negative 5. Number 21, this one's probably a little bit easier than 19 because I've got 3 and 9. However, right, 3 squared equals 9. That's kind of the trick I'm going to use here. So we'll have 3 to the 6n minus 5 equals 3 squared to the 4n minus 3. So what this is going to turn into, guys, now that I have the same base, I can basically get rid of them, and I'm left with 6n minus 5 equals 2 times 4n minus 3. So distribute that 2, 8n minus 6, and now just combine like terms. So I've got 6n plus 1 equals 8n. Subtract 6n from both sides. Oop. So 1 equals 2n. Divide both sides by 2. So n equals 1 half. 19 is going to be kind of the trickiest one because you have 3 and 81. 81 is actually a power of 3. And 81 actually equals 3 to the 4th power. So that's the trick I'm going to use. So I'm going to leave the 3x minus 5 alone. And I'm going to turn 81 into 3 to the 4th. And now I've got the same base, which means really the hard part's over. Now just 3x minus 5 equals 4. And solve it like you normally would. So 3x equals 9. Divide both sides by 3. X equals 3. So there's a practice sheet associated with this, and go ahead and pick your way through it, work together, and the next video will show you how to work through those.